Hello and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, looking at tools, libraries, graph systems built on the TinkerPop framework, or even applications built on those foundations. And today we're going to be talking to William Saffery about his GQL to Gremlin transpiler. Welcome, William. And how are you today?
Thanks, Stephen. I'm very good. I mean, I just woke up, but
Yeah.
yeah. I'm good. Excited to talk about my project.
All right. I've been trying to remember about how long ago did you first come to the TinkerPop community with the idea of building something like this? Because I mean, I just remember it popping up randomly in Discord one day, and we were like, "Oh, that's interesting." And then you just kind of came back, and all of a sudden you're like, "I have something." So, do you remember when this all about started?
Oh, I want to say I'd been I'd already decided I wanted to do a project for my thesis. And I kind of didn't want to like talk about it a whole bunch because I didn't want someone else to be like, "Oh, it's a really good idea. I should do that." but basically, I talked about it with some people on the TinkerPop Discord, you guys as well. I don't know, like I want to say like 4 or 5 months ago or something like that. Yeah, I don't know. And then I was like, basically, you got a lot of knowledge on that Discord. Generally a lot of knowledge about using TinkerPop in the community, which I guess you'd expect because it's a TinkerPop community. But yeah, so it was useful to chat, in particular about some matched up stuff. And then I came back and I'd like done it. Yeah.
Yeah, no, it was very cool. And now we're here today. Excited to see this. I think let's get your slides up here on the screen.
Oh, yeah.
And I will turn it over to you from here.
Yeah. All right. Cool. So this is sort of basically just the presentation I gave at the end of my thesis to the academic people. So, but like when I present this, I'm going to sort of strike a middle ground between what I did then, which was for academics who know nothing about Gremlin, and also people watching the stream, which may know more or may know less. So yeah, just some context. But basically, what we're talking about here is GQL to Gremlin, and some outline, which are basically covering sort of everything in the thesis. And just quickly, in case anyone isn't super familiar, a graph database is a database that implements a graph data model. So instead of having a bunch of tables which you join together, you have a bunch of nodes and edges, and usually you'll group those nodes and edges by like labels. And in the RDF model, nodes and edges just have labels, so that's all your information. And in the property graph model, nodes and edges have labels and properties. So this is kind of like very amenable to a sort of NoSQL, very flexible database. So that's what a lot of people focus on, and it's what Gremlin is for. So, yeah. And then what's GQL? Well, GQL is this new ISO standard, which I'll talk a bit more about it in a minute. But basically, there have been a lot of declarative query languages in the graph query space, which is sort of a different kind of language to what Gremlin is, and I'll talk about that in a second. But basically, all these languages have existed for quite a while, and a lot of them have had their features drawn on to create GQL. And I'll talk about why that's significant a bit later as well. So our goal is basically to have the user write GQL, to have them pass it to our system, and then have that system pass it to a Gremlin database, just any Gremlin database, because it's like TinkerPop is portable, and then get results out of our database, and then pass it back to the user. So that's the main idea of the project. And I did this in a thesis, so I wanted to like properly evaluate it sort of academically. So I used a labeled subgraph query benchmark, the LSQB. And if you want to actually see like the code, it's on my GitHub. Pretty short link, you can type that out. Anyway, basically, did I miss a slide? I feel like I missed. No, okay, weird. I just feel like it's a weird order. So GQL is like this declarative and SQL like query language. And Gremlin is imperative in Turing complete, right? So you can iterate in Gremlin, you can branch in Gremlin. Thank you for the link. you can do a lot of different, and there's like really powerful high level primitives in Gremlin as well. It's not just like a toy, you know. It's not like one of those languages which is made to be Turing complete just for the sake of it. You can do a lot of interesting graph computations in Gremlin. So there's value to these two different languages. And if we have a transpiler, which allows Gremlin databases to run GQL, then users can benefit from, maybe GQL is easier to write for like their query. Sure, they can benefit from that, but they can also benefit from, well, Gremlin definitely does a lot of things GQL can't. So that's kind of the idea here. You can write both. Anyway, why transpile GQL to Gremlin? So Gremlin's like, it's been a standard in the sense that we made it and we sort of standardized it ourselves in the open source community for a very long time. And there are like over 20 graph databases that support it. And we have TinkerPop standardizes Gremlin. Great. GQL is a new ISO standard, which makes it exciting to support on Gremlin. But it was only released in April 2024. And when I made these slides, I was only aware of 2 databases that claimed to support it. I now know Spanner by Google also claims to support it, but Spanner is very explicit that it's work in progress. All these, like if you look at it, it's pretty clear that this is a work in progress feature pretty much everywhere because it was just released, right? And native support of query languages takes a while to write. So, transpiling to Gremlin. This has been done before. You know, I'm not the first person to come up with the idea of transpiling this sort of declarative SQL-like graph query language to Gremlin. SparkQL, it's for like the RDF standard. And the idea is you can use the standard RDF query language in Gremlin if we just compile it to Gremlin using like the match step. And the match step basically is sort of like a sub DSL in Gremlin, which lets you do declarative querying, but it's not as complete as some other ways you can match subgraph queries in Gremlin, which I'll talk about later. Anyway, basically, we're going to benchmark my system, and so I want it to have a fighting chance, and so we're going to want to optimize it a little bit. And the most significant gains in optimizing subgraph query matching comes from the ordering that you actually match. So if you look at that pattern on the left, and so this is just a labeled pattern, so we're not, person 1 might have a different age. We have no clue what its age is. We're not conditioning on any of the properties of these elements, only on the labels. So just keep that in mind. And we're going to probably, it's going to come up later. But person 1 is like a person node, and then we need it to have a nose edge to a person 2, and then we need that person 2 to have a creator, to be the creator of a post. Basically, we need to match all these like predicates, graph predicates, in some order. And the order that we match those in is very significant in how long this query is actually going to take to evaluate. And this is basically finding the best order is called the joint ordering problem. So I'll move on. Basically, in the literature, there's a database which is very, very comprehensive in how it approaches optimizing its query execution, and is also a graph database. It's called KuzuDB. Now, it executes Cypher, not Gremlin, so it's going to be an interesting thing to compare against. But basically, it has 2 very significant features. It has a very high focus on this worst-case optimal join idea, which in the graph database world, you can think of this as if you have 2 nodes and you want to know what a neighbor they share, you take the list of adjacent nodes to node A and the list of adjacent nodes of node B, and you have to intersect them. And if you do that, that's faster than if you actually stepped through either lists and then looked at the adjacencies of the adjacencies. That would be slow. And then the other thing is like factorization of intermediaries. And that's the idea that if I have like a graph pattern and I'm storing in memory A and then all its adjacent nodes B, C, and D, and then all their adjacent nodes E and F, but then E and F all have A, you can like fold it in. So instead of having A, B, E, A, B, F, you would just have A and then a tuple, and then there's like B and then like a tuple and then E, F. So you basically deduplicate information. Yes, I don't know if I perfectly characterized factorization, but I tried my best. I'm more familiar with worst-case optimal joins. Anyway, basically, what we do before we do any of that is we need to pass GQL to Gremlin. And so we're taking, here's some GQL code. We're matching, and so on the right side of the colon here, we're looking at like the label. And on the left side, we'd be looking at a variable. So OP is like the variable name of that person node in the middle. But that probably actually doesn't need to be there because it's not referenced anywhere else. But there you go. That's what that is. And we can convert that to like our AST, which I've just like represented graphically. And it's just like a list of all the patterns, the path patterns, and also a list of the return items in a format we understand. And then I have this, I call it a static compiler. It's static in quite a few ways. Firstly, you'll notice that the code it's generating isn't based on the match step. And I'll probably talk more about the significance of that later. So it just looks like normal Gremlin code you might write, but because these patterns are quite long, it's a bit longer than write. And then also, it has the exact same order as the patterns in the approximate AST. So you see we're capturing the tags first, and then we're going to the has tag thing, etc., and so on and so forth. But because we have the exact order of like the query in that approach, that's not good enough, right? I want to optimize that ordering using like a join ordering algorithm. So what we're going to do is we're going to put an optimizer between our AST generation and our rigid transpilation, and we're going to optimize the AST so the AST basically corresponds to a better query, which does the same thing, and then we're going to compile that. And so we're going to look at this Gremlin code. We basically have two pieces of Gremlin code which are important here. One for the cardinality of label triplets, and one for the cardinality of nodes by label. And so what this is going to let us do is it's going to let us go to the database and say, hey, database, give us all the stats about how, like the cardinalities of everything. And then later when a query asks us, okay, I want the persons and the people who know the persons and the posts that person has posted, we can be like, okay, well, I know the cardinalities of persons knowing persons. I know the cardinalities of persons who have posted. And then I can reorder this in a way which is optimal. Now, notably, this is only going to work when the most significant factor in the query is basically the label predicate, because this only cares about the counts of the label predicates. But I think that's generally going to be a significant factor. So this is always going to basically marginally improve, at least. But in our case, because we're always looking at just labeled queries and no properties, it's going to basically do all the improvement necessary. The only thing missing is the algorithm. And so we're going to look at all these counts, and we still need to figure out, okay, well, what is the best ordering? And so what we do is we sort of greedily select an ordering. We start with, we check from each starting node we could start from, like, oh, what's the best triplet we can select from here? And then, oh, the best triplet we can select from there. This is not optimal. So actually doing this problem correctly is MP hard. And I think in the more mainstream databases, they'll use like a dynamic programming approach to cover everything and then like have a time-based cutoff or something. We don't do that, so we might lose out to some of those more mature databases, but we just want to show that this beats not doing this, basically. That optimizing ahead of time is better that they're not optimizing at all, or doing what match step does, which actually it tries to optimize adaptively at runtime. So anyway, yeah, as I was saying, because the transpiler we talked about before, which goes from the AST to Gremlin, is rigid, it just interprets the order literally. We can simply reorder our AST using that optimizer and then turn it into Gremlin code. So now we have post at the start. Is that reordered? I think that is reordered. Oh yeah, you see, okay, so post is now the start of every path pattern. Instead of being like a snake, it's now like a star. So that's interesting. Anyway, we're going to benchmark all this using the labeled subgraph group benchmark, which is basically designed to stress test systems. So in the original paper, it was really large data. Our data is still going to be quite large but smaller. But it's really like simple queries with like conceptually simple, but actually like complex to execute queries. So we have like cycles here. We have like all these edges around here. I don't know. Can they see my cursor? Sorry.
See your cursor?
Yeah, I think not.
No, don't see your cursor.
No, don't worry about it. So query 3, it's like complicated. There's a lot of edges. Query 2 is like cycles. So we have a lot of different things going on here. And we just want to measure how fast are we on a quite large data set at counting how many of these subgraphs are there. And they're just labeled as new properties. So basically,
could I pause you for 1 second?
Yeah, go
on. There was a question that came up through Discord.
Oh yeah, sure.
Yeah, from Arthur,
Yeah,
our good friend over at G.V.
Yeah.
He wrote that in terms of implementation,
Yeah.
is there any reason behind the choice of an Antler grammar implementation? So you can kind of see the question there. He's come across a more official grammar. What are the potential divergences between your version and the official one?
Yeah, so I've seen the other grammars. There's actually quite a few. So there's there's TwoGraph, who I showed on the screen earlier. They have their own grammar. I don't know if that one is the TwoGraph one, or that might be actually like a more independent GQL one. And then there's Olaf Mora, who wrote the grammar, or like the initial state of the grammar, which I then modified. So I guess you could think there's like maybe 4 grammars out there. Divergences, yeah, probably plenty. I picked my grammar because that's just what I found when I was researching this project to begin with. It's not necessarily the best one. It's correct for what I do. So that's all that matters for now. But yeah, there could be divergences. And it might be better to adopt a more official one if I was to extend this project significantly. Yeah,
that's interesting that there's differences and that there's 4 of them. Is there any?
Actually,
I'm curious.
I can tell you 100% a difference. So you'll see whenever I talk about iteration, I don't know if I'm actually going to talk about it in the rest of the presentation, but I did have it earlier. I'll bring it up. So this iteration, you see how I use square brackets. This is basically just a mistake. It should be round brackets. There was an old paper in GQL which used square brackets before the standard was released, and I just went off that paper. And I think also so did Olaf Mora, but that's not actually what's in the standard. I do actually like it better, but I will have to change that because like that's not correct.
Gotcha.
But it's semantically the same. Yeah.
Okay. Yeah, that's interesting.
Yeah.
I mean, I think Arthur called. I guess you were kind of worked on this before there was like any official sort of implementation in place.
I was sort of trying to work quickly to get it out, but also like you run the risk of things changing, and then like you're no longer perfectly correct. But it's still good enough to like be most of the way to GQL, because then it's just a matter of modifying it so it matches the standard.
Yep.
Yeah.
Okay. Cool.
Yeah. Anyway, we've got quite small data, very small data relative to the original benchmark, but still quite big on my PC. Like when I load it into any database, it slows down, doesn't run in memory, or whatever. Although I guess it technically should fit in memory, but desktop environment, etc., etc. I don't know. Anyway, we have a 30-second cutoff time, so anything longer than that is considered a did not finish. And this is just a small work laptop. Anyway, so we benchmark our code, and the idea is we look at the GQL code compiled to Gremlin, the GQL code with the AST optimized and then compiled to Gremlin, and then we also have this like match step, which is just handwritten. So I try and write it to be fair. I'll talk about it in a second. And then I have Janus graph, but I'm only running it using the Berkeley Java backend, which is not the best. And I'm also only running it on one computer, so not distributed. And then I also have RKDB, which is also worth keeping in mind, does not consider Gremlin to be its primary support. So my Gremlin systems, basically, I'm saying ahead of time, are not great, but they are Gremlin systems, and so I can test performance on them in some ways. And then we also have Neo4j, which is very mainstream database, and we have KusuDB, which is that research database I talked about before. So not very mature in that sense, but it runs Cypher, so it works. And I was saying I use that match step I make sure it has the same initial ordering as a GQL and Cypher queries. So I actually first came up with the idea of looking at the match step code written by someone else to make it like more human written. And GraphScope people have written their own match step for LSQB. But the problem was that with that is they reordered a little bit, like the ordering of the joins versus like Cypher and GQL. Well, there was no official GQL, I just converted it from Cypher, but as opposed to the Cypher queries, which isn't really fair. Because I mean, you could just figure out what the best ordering is and reorder it, and then your code will just run faster. So I changed it back, and then the match step should gradually change that order, which is what the match step does, by the way. It keeps track of the cardinalities of the intermediaries, and then it should switch the orders or the patterns it's evaluating over time. But I have found in practice that it doesn't really do that often. But we will see. And so that's that idea. Anyway, I benchmarked Janus Graph, Arcade B, as I said before, Neo4j and QZ. And so I guess I have a few different results. But one of the, I guess, nicest results is that I have this optimizer and it works very well, right? So I'm going to label an improvement as 100% if previously, before the optimizer, it ran over 30 seconds, so it didn't finish. And with the optimizer, it ran under 30 seconds, so it did finish. But you can see that like there is like 4 like improvements from DNF, and then like quite a few improvements of like 40 to 50%, and only 2 improvements of like under 10%. And then a couple where everyone DNF'd. So it's really yeah.
Yeah, and so those were all like the match step style written.
No. So this is going from but good point, good question. This is going from the GQL to Gremlin without the optimizer, so just no ordering better.
Oh, okay.
Just the ordering as given, and then from GQL to Gremlin with the ordering optimized. Yeah, that's what.
Okay, so it is your So then, yeah, I'm curious. I don't know. What the queries are and what Q1 through Q9 are. I'd be curious to see.
For sure.
If you show that eventually, that's cool. But I'm just kind of curious what the generated stuff looks like versus what maybe, I don't know, I might write for those things.
Yeah.
But okay, sure.
For sure.
I got it now.
For sure. Yeah. And then, so I have like a main improvement, whatever. You can see it's like approximately.
Yeah, cool.
30, 40. And then, so this is when we start looking at match statement as well. And so what we see with the match step is that generally the optimized GQL to Gremlin always beats the match step, except for Janus Graph's match step being very proficient at query 3 for some reason. Now, Janus Graph, it's really hard for me to figure out the relative strength of match versus GQL to Gremlin on like a per database basis, because it seems to like go back. I want to say Janus's match step is better than Arcade's, but that doesn't really make sense because they both use the exact same implementation of the match step. It might be that Janus uses an underlying batch step, which is better for like that movement between the vertices. I'm not sure. But basically, in general, the optimized GQL to Gremlin does do better on both systems anyway. So there's that. I think Gremlin Janus is closer to GQL to Gremlin Janus. Not sure. But yeah, we basically match statement does not perform that well. We have the somewhat unfortunate result that Neo4j and QZDB tend to significantly outperform these Gremlin systems. And yeah, there's not really much else to say there. There is quite a strong outperformance, but there are some cases where Arcade is par, which makes sense because it's the one which is probably closest to its ideal environment. Anyway, basically, some limitations here is like we only tested the performance of our system on the LSQB. And that's a very limited subset of our functionality. And so we have like a set of functionality tests. And I think I'm going to get up a screen share and show like some GQL code that you could run, which would not be tested by this after. And then we only tested a few Gremlin systems. And the ones we did test are not in ideal environments. Yeah. So Arcade DB doesn't treat Gremlin as first class, and Janus Graph is pretty much designed for a distributed cluster. So I tried to get up and running more databases which like treat just running Gremlin as like a single core, just like run it as fast as you can, whatever. We treat it as first class. We are optimizing for it. It was hard to find any I could run locally. I think there might be better like cloud provider ones, but I wanted everything to be running in the same place so I could actually compare like to like. So that was a pretty big reason there. Anyway, some future work. I mean, people are going to be implementing GQL with native implementations in the future, and it's just going to get better and better, I think. But there's like a use case for more transpilers. Like I said before, I think the idea of using Gremlin and GQL is still compelling in the same database. There could be a new stranded traversal language which is better suited for a subgraph marching problem. So I think the worst case optimal join idea I was talking before with which Kuzu does, I think is reasonably easy to implement. And Gremlin could add it, but it also might be a little confusing to a user because the thing which is quite nice and interesting about Gremlin is each, like the mapping between the bytecode and the language is nearly 1-to-1. And so when you start adding stuff like a worst case optimal join step, that's like, well, what does the user think of that? You know, it's sort of like very optimization focused, but it could be done, I think. So that could be very helpful. And you could also automatically apply that using like the automatic optimizing traversal optimization thing that Gremlin has. Anyway, transpiling GQL to Gremlin, it's like basically it looks like it has pretty good applicability and flexibility in comparison to like using match step or just handwriting it. Maybe we'll see what Stephen thinks about that when I show him the queries. And then yeah, the tested Gremlin database is underperformed in the LSQB, but it's not too surprising. The other databases are basically designed for this kind of problem. The LSQB, it's not exactly always what you would do on Gremlin, and they weren't in their ideal environments. So there is that. And Kuzu seems very effective, especially for that problem. This problem. And so I have a bunch of references here. I think I've linked to everything which is like an image that I used. And if you want to like find the source for claim, you can find it here. I'm just going to leave this for like 2 seconds. People can come back later. But yeah, that's pretty much the whole thing.
Okay.
Yeah.
Could you say a little bit more about going back to your kind of future work?
Yeah, for sure.
Yeah. Could you say a little bit more about like, so, you know, how much of GQL is sort of is transpilable at this point? You're talking about larger subsets of GQL.
Yeah,
where are we at with the subset we have now?
Yeah, sure, for sure. So subset we have right now is read only. So like writes is very doable in Gremlin, and I think, to be honest, I haven't looked exactly at like how GQL does writes, how Gremlin does writes. Is that transferable? But intuitively, I think it would be. So I think that we could add basically all of the writing stuff in GQL. One thing we can't do right now is Gremlin. Oh, no, sorry, not Gremlin. GQL has this path pattern mode thing where basically you can say, I want to match this mode, this path, but it has to be acyclic. So it has to not repeat any nodes. Or I want to match this path, but it has to be a trail. So I don't want to repeat any edges. Kind of like, not like Cypher, but sort of similar in concept. And then also I want to match this path, but I want it to be simple, which means not any repeating nodes, but you're allowed to repeat the head and the tail. These like, we can do acyclic on Gremlin fairly easily, right? Because we have the acyclic step, or we have a simple step, which corresponds to acyclic in GQL. But we can't do GQL simple, which allows head and tail. Well, we can, but it's harder. And then like the trail thing is basically impossible in Gremlin. I mean, you can do it, but it's just so hilariously inefficient. Basically making sure none of the edges repeat. So there's that. And there's like a bunch of other like smaller things you can do in GQL, which I'm not super familiar with. Like in the return statement, I know in Cypher, so in GQL, we have iteration. Let me just bring that up again. Once again, most fun part, right? So this ease thing is like a list here. And so like as it basically, we're going to have this pattern is basically going to unfold into like 5 different patterns. One where there's only one nose edge, one where there's 2, one where there's 3, and one where there's 4 and 5. And everything that nose edge matches in the row for that result. So I guess each pattern is going to bring about a bunch of result rows, but in each of those rows is going to have a list which corresponds to E. And so you can just return that list, and so you can have like this sort of nested thing. Or you can count it, or you can like fold over it, aggregate it. There are various different things you can do in Gremlin. I don't support any of them. Actually, this count thing won't even compile on my thing, so that's still to be done. I think that the count thing would be really pretty easy. Count local, we know the Gremlin stuff, because this is actually just working out to be like a local variable in the list form in Gremlin. Yeah. But I don't know. There's probably more to be done there.
Okay. Given your knowledge of both GQL and Gremlin at this point, where do you think I don't know, where do you feel like they work sort of best together? There's things Gremlin does, there's things GQL do. If they were to somehow work together in some way, what would you think would be ideal?
Yeah, so I think we were talking about this a bit before, but basically, what Gremlin currently has is this match step, which does declarative matching. And then it like drops out this dictionary you can use, and then that's pretty much it. That's cool, but like GQL and both the match step, but in general, declarative pattern matching in Gremlin, I feel like could be a little better integrated. So if we've talked about a GQL step just on chat, but the idea of a GQL step is you have a string and you pass it to a step in Gremlin, and the string contains a GQL query, and then basically the database runs that query and then returns you results. But I was thinking if that's to happen, and also like I would like, even just with match, if this doesn't happen, I would like to see it, is like in match or in such a step right now, what happens is you get this dictionary as output and you can no longer traverse. Like you can't select different nodes from that dictionary easily, and then like have like their path history if there is any, and then continue from there. So sort of like better integration of the results of like a declarative query in Gremlin, and like continuing that traversal I think would be good. And then you could really see people have like this Gremlin query, do some complicated stuff. Oh, thank you, cool. Yeah, for sure. And then like a simple graph pattern if you need one, which might be on like something with a very high cardinality sort of differential between the different node sets that you can just leave to the optimizer to figure out. You don't need to think about it too much. And then you continue and you do another complex computation after that. And then that could be good, I feel like. So that's sort of where I see them meeting together. Okay. But also just like another thing you could think about is, well, there might be like different sets of people working on the database with like different needs in terms of complexity, right? Someone might be doing like, oh my god, I should just have it on speed out. It's slide 6. Someone might be doing something which really requires like this sort of eigenranking of like the node names or whatever. But someone else on the database, they might not even need iteration. They might just be doing simple graph patterns. And then so like if it's the same data set, you don't need to move it, you don't need to update it, and both people can query it very simply.
Gotcha.
Yeah.
Okay. Yeah. Cool.
Yeah. I can get up a screen share. I've noticed we have been running for 40 minutes.
Oh yeah. I mean, I have time if you have time to keep going a little bit.
I have time. I have time to go to like an hour. I was just making sure that you don't know anywhere to go.
No. Go ahead.
Yeah. Okay. Cool. Well, maybe I should pull up a screen share.
Yeah, that'd be great. I'd love to see some like what's generating, and if that's something you can show.
Yeah, for sure. No, I can get it up and show all that. What's missing from TinkerPop to make it an easier target for similar projects? Okay, there's a few different ways you could approach it. I think the best thing, what is it? Nothing is really missing if you don't care too much about performance. If you care quite a bit about performance, you'd probably be concerned with a worst case optimal join step. Maybe something that's missing is like the idea of having two different traversals which execute in parallel and you can join. But I think that might actually not even really be necessary. to get good performance. Maybe it'll be an easy way to help improve it, but I don't know. It basically, I guess what's missing is a couple of steps that would help providers, but might not actually be like super intuitive for users. And so like how we remedy that as like TinkerPop is like something to think about. But yeah, worst case optimal joins, maybe parallel execution is probably what I would say.
We've largely, I mean, TinkerPop has largely, delegated that responsibility
to providers.
I do think there's room to try to do more. There's actually, if you probably dig around,
there's a few, right? Like the batch step, I think, is built into TinkerPop.
There's a few things like that. Like if you dig into especially if you dig into Jira, if Yang hasn't closed the tickets,
gotcha.
There's there is something about sort of parallel traversing kind of built in there. And traverse multi-directional and keeping stats and trying to figure those things out. I think it's a little hard to build when you're the framework, but maybe it could be something that's there. It's just that typically it's been left to providers to kind of figure that out. I do think like Janice Graph would appreciate more of that stuff in TinkerPop. For anyone who wants to dig into something for the community, I think like Janice Graph community would like that. I think obviously maybe not such a great thing for TinkerGraph in particular because it's just TinkerGraph, but there's definitely some graphs that could probably make use of that.
Benefit. Yeah, sure. Yeah. Well, hold on. Let me get up my screen share right now.
Okay.
Let's hope that works. Okay. Okay. Seems promising. Okay. All right. Cool. Can we all see that just fine?
I'll put it up there. Hang on.
Oh, yeah.
I guess we got to get rid of this guy and that guy.
Oh, hello. See like this time? Yeah, I think so. Okay. All right. So, all right. I think we're up. Check. No, am I crazy? Yeah. Are you all good, Steve?
Yeah.
All right. Maybe I should just minimize. Oh, I'll move this over here. Right, that makes sense. Okay. All right. So, basically, I have my project right here. I have.
You might want to make it a little bit bigger with the text.
Oh yes,
just a little tiny bit. I mean, I can see it, but maybe for the stream, it'll end up being a little fuzzy. I'm not sure.
Try my best.
That looks good.
Yep. Okay. Cool. So I brought up just like this query 4 because I think it's gonna be the easiest to read, maybe. And so actually, maybe I should go for a different one. How's query 3 looking? Too long. Query 2. Okay, great. So we have person 1 knows person 2, and then person 1 is like the creator of a comment, which is the reply of a post, which was created by person 2. This is like the thing. There was no new line at the end of that, which is annoying. But anyway, what I'm going to do is I'm going to run the app for I think it's GQL Gremlin script app, and I'm just going to say dash query GQL /LSQB /create2.gql, and that's not going to error at all, right? Yeah. Okay, great. And so here we have So just to be clear, because I think I've confused a little people about this, but it doesn't matter too much. In the code, I'm using like the Java DSL to generate Gremlin traversals, and then when I output this as a Gremlin script, I'm actually like converting those traversals to Gremlin script, which is nearly lossless, but not exactly the same. So there is that. But this is a pretty good approximation of what I sent to the database.
Yeah, that's getting a lot better. So you're just using the translator things to do that?
Yeah, the translator things. Yeah, I was gonna say. I was thinking. Thanks to a forum post by you, Stephen Mallet, I think I figured out how to do this.
Yeah, those are going to get a lot better going forward because they're going to be grammar based rather than the old way we kind of used to do that. So it should be getting closer to being like a perfect representation of the original Gremlin, which has always been a bit of a problem with the translator. So okay, cool.
Gotcha. Well, I haven't had any problems. So basically, a recent update actually to the translator. So in the lecture slides I showed you, whenever I was going out for an edge, I always had like the out, right, birth, or whatever. That was sort of a half lie. So actually, the compiler would always, if we need to save an edge so we can like count it or like select it later, we need to actually go to E and then like go as on that edge and then go like out V, right? Or we need to go, out E and then like in V.
Yeah.
So we can like actually interact with that edge. But we don't always need to interact with that edge. And I just recently added it that if we're not interacting with the edge, we will use like that birth or like out, and then we'll add like the label set there. So that's nice. That's actually good and working. And then this is like what the query looks like. And then here we have, just for memory, the person 1, person 2. So we actually do that exactly in that same order. And I don't know what you would handwrite for a query like this. Personally, I would just use the match statement. So that's sort of like the thesis of my thing. Like if you were to look at this and think about how am I going to write this in Gremlin, well, you either wouldn't or you would use like the match statement. So this is like not really what you would write as a human, maybe. But if you were, then like if you would write this, then at least I wrote it. Maybe. I don't know if you can think of another way you would write this. In general, when you're doing aggregations in Gremlin, there's like other ways to do things. But I don't know. Anyway, but I can also go q2.gql and I can go compiler optimizing. And then that is going to reorder things. So now we're starting from, then we're going to parse. And this is just going to run quite a bit faster.
Yeah. I guess I don't know offhand what I would particularly write. I think I guess, like I say, I don't see anything particularly like crazy, right? I've seen nothing. Sometimes some other translations are like, oh, wait a minute, I don't know that that's what we would do at all. But like this, this is something I tend not to select a lot usually in a lot of the Gremlin I write. It's usually more like projections to get similar sorts of results. So you get kind of a slightly different result than a different looking result than you might get that folks are typically used to getting out of like a cipher type query. But I mean, I think when you're trying to match the output of the table like structure, it ends up looking more like what you have here. So
so
interesting.
It's exactly what I'm thinking about. I've seen like your posts and like the sort of queries you post online, and I see you do that project stuff, and it looks like the output is in some ways a little different to what you'd expect from these queries. So I can't use it, but I am aware that there is different ways you can push out Gremlin, and it might be better or worse, who knows. And so I can also just quickly get up like a run my, this is like a custom script, but it doesn't actually do anything significant. Run Janus graph, and that should be preloaded with the LSQB dataset, and then I can execute this. So let's hope I get this name right. Run remote db app. I think that's right. And so there's default arguments for the application. That's all going to just default to my Janus graph setup.
So when you did your benchmark, that was all for both ArcadeDB and for JanusGraph. You used a remote connection to do that. So it was all executing remotely.
Yeah. So that's all using the Gremlin remote traversal stuff.
Okay. So
it's running
gotcha.
locally. Yeah. The idea is I want it all to be like basically portable.
Yeah.
It's using the TinkerPop standard.
Okay.
So anyway, that works. So that's cool. It takes 14 seconds. That's with the optimizing one, and we can see what happens. I mean, there's like a bunch of different ways. Another thing like is if I get up, had that like Gremlin, anything else could be Q2 Gremlin. Like this is what we have. There we go. Okay, this is what we have for like the match statement, which is definitely cleaner to read, But if I execute that, it would not take 14 seconds. I don't know how long it would take. It might actually run over.
Okay, cool.
Yeah.
Cool. All right. Yeah, nice.
Yeah.
Let me see. Are there any other questions anyone has? I don't see anything else in the chat at the moment, but feel free to throw any other things in there. I guess let me see. Any other comments from you, William? This has been really nice. I think it's been a great presentation. Anything else you'd like to share?
Not a huge lot. I think I'll probably continue working on the transpiler maybe in some capacity. I might look at like the Tinker graph updating stuff. I don't know. I do have a holidays to have, but we'll see. So I guess keep your eyes tuned for integrating GQL with Gremlin. If you're interested in helping integrating GQL with Gremlin, maybe talk about it on Discord. I might send you a DM. And yeah, I don't know. It's been a fun project. Keep tinkering.
Yeah, no, good. Yeah, it sounds like you enjoyed what you were doing to get this much done. Again, what it was, I thought, a pretty short period of time, actually, from what I can remember. And then you told me about how long ago it was. I was like, wow, okay, yeah, we got you definitely got some stuff done. So yeah, but appreciate you coming on here today and sharing this all with us. I'm sure folks are going to be kind of watching this when it finds its way up onto YouTube. And like I say, until the next one, everybody, thank you, William. And thanks everybody for watching today. Take care.
Take care.